So we're looking at Pythagoras' theorem. Why is Pythagoras' theorem important? Well, it's important because it's used a lot in real life. It's used in architecture, it's used in building construction. It was actually used a lot in animation. For example, in the Shrek films, a lot of the faces, the shapes were actually made using Pythagoras' theorem. So now that we know what it's used for, it's important to know what it actually is, what the formula is. And the formula is a squared plus b squared equals c squared, okay? And if I draw a triangle, and it's very important that the triangle is a right angle triangle. If it's not, then Pythagoras' theorem wouldn't work. Now, A is one of the shorter sides, doesn't matter which one, and B is the other shorter side, so again, doesn't matter which one. Now, what's important is that C is always our longest side. So there we can see a triangle with sides A, B, and C. Now, if I gave these a value, so if I gave them a numerical value, for example, if I said that A was 7 centimetres, B was 9 centimetres, and I wanted to calculate C, well, that's where Pythagoras' theorem comes in useful, because using a theorem I can say that 7 squared plus 9 squared equals C squared. Now, being brilliant mathematicians, we all know what squaring is, and we know that 7 squared means 7 times 7, which is 49. So it's 49 plus 9 times 9, which is 81, equals c squared. Now, 49 plus 81 is, of course, 130. So 130 equals c squared. And now we've got a linear equation. So to find out what c is, I need to square root both sides, which means that c is equal to 11.4, and of course I've got to remember my unit, so it's 11.4 centimetres. Now we've looked at 1 and we know what A, B and C are and what Pythagoras' theorem is, let's look at another example. Okay, so this time we're looking at a right angle triangle with sides of length 10 centimetres, 5 centimetres and x centimetres. Now, I called it x because this is what is most commonly called in GCSE questions. Remember, in algebra, a letter is just representation of a value that we want to find. So instead of calling it c, this time we're calling x. So we write down the formula, a squared plus b squared equals c squared. Again, let's label our sides. So 5 centimetres is a, 10 centimetres is b, and x centimetres is c. Which means that a squared, so that's 5 squared plus b squared, which is 10 squared, equals x squared. Now 5 squared is 5 times 5, so 25 plus 10 squared, which is 100, equals x squared. So 125 equals x squared. Again, we square root both sides, and that gives us, well, the square root of 125 is 11.2 centimetres equals x, and it really is as simple as that. Now, we can use Pythagoras' theorem not just to calculate the length of the longest side, but also the shorter side, so we can use it to work out A or B. So let's have a look at an example where we work out A or B. So this time we're going to look at a right angle triangle. Now remember, again, right angle triangle is really important because unless it's right angle we can't use Pythagoras' theorem. And this time, instead of trying to work out C, we're going to work out the length of the shorter side, which is A. So again, let's write the formula down. A squared plus b squared equals c squared. And label our sides. We've got A and we've got B and C. So this time, A squared plus 7 squared equals 12 squared. Now, the difference between this and previously is we were given the formula and we could put our numbers straight in. This time we're going to need to rearrange a formula to find the value of the unknown, which in this case is a squared. So we should all remember how to rearrange formula, and if I want to get rid of plus 7 squared, and I take it away from both sides, which gives me a squared equals 12 squared, take away 7 squared, which means that a squared equals 144, take away 49. So a squared is 95. Square rooting both sides tells me that a is equal to 9.7 centimetres. And I should know if my answer is right or wrong, because remember The longest side is always a hypotenuse. Hypotenuse just meaning the longest side, so that's always C. So A must be shorter, well, must be shorter than C. And in this case, we can see that 9.7 is less than 12 centimetres, so I can guess that's probably right. And we'll look at one final example, and this time we'll use it to work out B. Okay, so this time we've got A and C, and we'll be trying to work out B. So let's label those A, C, B. Let's write down the formula. A squared plus B squared equals C squared, and substitute into the formula, meaning we got 15 squared plus B squared, or in this case, sorry, I should say X squared, because that's what the side's been called. So 15 squared plus X squared equals 23 squared. And now, again, let's rearrange it so we can get X squared on its own, because that's what we're trying to work out the value of. So I want to get rid of plus 15 squared, so I take 15 squared away from both sides, which tells me that X squared equals 23 squared, take away 15 squared, which means that X squared is equal to, well, 23 squared is 529, take away 15 squared, which is 225. So X squared equals 529, take away 225, which is 304. And as we've done before, we just need to square root both sides to find out what X is. And if I square root 304, I get my answer, which is 17.4. And of course, this time, let's just look at our units. And like the other questions, it's not centimetres, it's in fact millimetres. So my answer is 17.4 millimetres. Again, if I look at C, C is 23 millimetres. My answer for X, which is a shorter side, is 17.4 millimetres. So I can be pretty confident that I got the right answer.